This is example 8 on section 13.5. So the two radii of the first term of the right circular cone are increasing of the rate 4 centimeters per minute. So we have two radius here, and the change of these two radius is going to be 4 centimeters per minute. That's mean D capital R, which is, that's what they say here, because the capital R, that's mean the change of this radius with respect to the T is equal 4 centimeters. And the same thing, the change of the small circle with respect to the T also equal 4 centimeters. And what else here? And the height is increasing of the rate 18 centimeters per minute. And that means DH with respect to the T is 18. And what else we have? Find the rate at which the volume on the surface are changing. So we need to find the change in the volume and the change in the surface when the two radii are 15 centimeters and 25. That's mean R 15 and capital R is 25 centimeters, and with the height equal 10 centimeters. So the height equal 10 centimeters. So all the information here, we're going to use it. So now, first of all, we're going to work with the volume. If you go back to the notes, the hint they give it to you, here is the volume, how to find the volume, which is the volume is going to be pi over 3 r small plus r capital plus r capital squared times h. So that's how we're going to find the volume. We need to find the change in the volume. So we're going to find the derivative. The derivative with the volume, there's 3 variables. In fact, there's 1, 2, 3, 4. No, this is a 3. The same. So the dv with respect to the t is going to be dv with respect to the t is going to be dv with respect to the r times dr with respect to the t plus dv with respect to the capital R times d capital R with respect to the t, and plus dv with respect to the h times dh with respect to the t. So we're going to find the derivative here and here and here with respect to the small r, capital R, and h. We're going to use here. That's mean dv is going to be over dt equal. If you look to this part, we already have this one, which is equal 4. We already have equal this one, and we already have this one, 18. We just need to find the dv over dr. Here is dv to the respect to the small r. So it's going to be pi over 3. I'm just going to work here with respect to the r. So I'm going to put a bracket. Here's pi over 3 h, because these are constant. We're going to find the derivative with respect to this r. So pi over 3 and h constant, and is going to be 2r plus capital R. Close it, because 2r plus capital R, this is 1. So dr over dt plus the same thing with the second one. Now we need to find the derivative with respect to capital R. So pi over 3 and h are constant. So with respect to the r is going to be small r plus 2 capital R and dr over dt. Then plus the same thing. Now with respect to the h, everything here is going to be constant and h is going to be 1. That means it's going to be pi over 3 r squared plus r capital R plus capital R squared times 1, and everything is dH over dt. Now let's look. We have R, capital R, and we have H, and we have dr. So we're going to plug in everything here to find the dv over dt. Is going to be pi over 3, and H is 10, times 2, R is 15, and capital R plus capital R is 25. Close the parentheses. And everything is times 4. Plus the same thing here, pi over 3, H is 10. And now we have R squared, that means 15 squared, plus 15 times 25. No, I have to work on this one. So R is 15 plus 2 times capital R, which is 25, and close the parentheses, and everything here is dr over dt, which is 4 also, and then this one is going to be plus pi over 3, and here is going to be R squared, which is 15 squared plus 15 times 25 plus 25 squared times 1 dH over dt, which is 18. So all these numbers, we just have to simplify everything. So let's work one by one. So on the first one, we have 10, 2 times 15, which is 30. 30 plus 25 is going to be 55, times 10 is going to be 550 over 3. 550 times 4 is going to be 2,200, or pi over 3. So here, that's mean dv over dt is going to be 2,200 pi over 3. This is the first one. Plus the second one, we're going to do the same thing, but be careful. So this is 50, 50 plus 15, and everything times 10, and everything is times 4. So it's going to be 2,600 pi over 3, 2,600 pi over 3, and here is going to be plus the last one here. This is 15 squared plus 15 times 25, and plus 25 squared is going to be 1,225, and everything times 18. And be careful, I think 18, you can simplify it by 3, but I'm going to keep it this big number because we can add it with this one. So it's going to be 2,2,0,5,0, and everything is pi, and everything is divided by 3. Now we're going to add these numbers and divide it by 3. So this one plus this one, just adding, plus the last number we got here, which is this number. So it's going to be 26. So dv over dt is going to be 26 268.50 pi over 3. Can we simplify it? I think yes. If you divide it, so dv over dt is going to be 8,950 pi. So this is the change in the volume for this shape. So we're just going to type here 8,950 and pi. Yes, pi. Let's check that. The next part of this question is going to be a little bit longer. Yep. Let's see. Now, the second part of this section, we need to find the surface. So here is the rule for the surface. It's already there. It's going to be a little bit longer. So they're saying the surface is equal pi r plus r and bracket, it's square root. So I'm going to change this one to r minus r squared plus h squared to the power 1 over 2. Now we're going to do the same thing to find the change on the surface. It's going to be ds with respect to the t is going to be ds with respect to the r times dr over dt plus ds with respect to the capital R times d capital R over dt plus ds with respect to the h times dh over dt. So now we're going to start one by one, and you have to be careful because it's really long steps. And here's our function. So it's going to be this one times this one, the product rule for this one. We're going to use the product rule. So ds over dt is going to be, going to open big bracket. And if you look here, pi is a constant for all these functions. So I'm just going to take the pi out and open big bracket. Let's start with this one. That's mean when you're doing the, just keep the pi outside. So it's going to be find the derivative for s with respect to the r. This one times this one, the derivative for this one, plus the derivative for this one times this one. This is the product rule. So I'm just working now on this part here. So it's going to be the first function, which is r plus r times the derivative for this one is going to be half r minus r squared plus h squared. We're going to put bracket here to the negative half. Plus h squared to the negative half times the derivative of inside with respect to the small r is going to be 2 r minus 1, r minus capital R minus r, 2 minus 1 times the derivative of inside, which is 1, for negative 1. See, that's why you have to be careful. A plus, we didn't finish from the first one. The second one times the derivative for the first one. The second one, which is, I'm going to close the bracket here. No, close the second one times the first one. Here is the second one, which is r minus r squared plus h squared to the half times the derivative. Let's keep it because I already put a bracket on the top. Times the derivative for the first one with respect to the r is going to be 1. And everything now dr over dt. Here's these two brackets. And okay, this is dr over dt. And this one now is going to be plus. We're going to open another bigger bracket. We're going to find the derivative with respect to the capital R. With respect to the capital R. So now the first one times the derivative for the second one. So it's going to be capital R plus R times the derivative for the second one is going to be half R, capital R minus small r squared plus h squared to the negative half times the derivative of inside is going to be 2 r minus r, 1 times the derivative of inside is going to be times 1. And everything here is a plus. The second one, which is this fraction, r minus r squared plus h squared to the half times the derivative of the first one with respect to the r is going to be 1. And everything times d capital R over dt. We didn't finish. Now this is a plus. Now the third, these two fractions with respect to the h. So the third bracket is going to be the same thing, the first fraction times the derivative for the second one. Here is the first one times the derivative for this one with respect to the h. So the same thing is going to be times half r minus r squared plus h squared to the negative half times the derivative of inside with h is going to be 2h. That's it for the h and everything with dh with respect to the t. Now let's check. Can we simplify it? This 2, I can cancel it with this one. What else we have to cancel here? Nothing. Here, this 2 cancel with this one. Let's use different. So I can know. This one cancel with this one. And this one cancel with this one. And this one cancel with this one. So we're just gonna, now the next part is let's plug in, because we already have almost the all information here. Before I start, let's do a hint here on the side. We already know R equal 15 and capital R equal 25 and H equal 10. I know this information. Now, R plus R is going to be the addition of these two, which is equal 40. And R minus R is going to be 25 minus 15, which is equal 10. What else we need to? H squared is going to be 100, because 10 squared is going to be 100. This all information is going to help us when we plug in here. So let's plug in. That means this one is going to be 40. This one is going to be 10. This one is going to be 10. This one is going to be 10. This one is going to be 100 plus 10 squared. And this one is going to be 100. This one is going to be 10. This one is going to be 40. This is 100. This is 10. This is 10. And now we just have to, and this is 100. The last one, this is 40. This is 10. This is 100. This is 10. Now it's easier to work on it by just plugging these amount. So here is the pi outside. And let's start plugging. This one is going to be 40. Open a bracket. This is 10. 10 squared. Plus 10 squared, which is the 100. To the power 1 negative 1 over 2. And then we reached here. This is 10 times negative 1 times 10 times negative 1. Plus, let's write down the h squared on the side. H squared equal 100. And plus, let's work here. This one is going to be 10 squared plus 10 squared. 10 squared plus 10 squared, which is the h squared 100 to the half times 1. dr of over dt, which is equal 4. So this is equal 4. Now we can simplify this one. We can simplify this one and distribute the 4. So let's move to the next one. Plus the second one here. So this one is going to be 40. So here is 40. And open a bracket. This one is 10 squared plus 10 squared, because it's s squared to the negative half also. And this is times 10 times 1 plus this is 10 squared plus 10 squared to the half times 1. And everything with dr of dt, which is equal, dr of dt is 4 also. Now this one is a plus. The third part is this is going to be 40. And here's 10 squared plus 10 squared, which is the 100 to the negative 1 over 2 times 10, and close the bracket, and everything with dh over dt, which is 18. Let's keep working on this one. So this is going to be equal. Here is the pi. We just keep simplifying. So let's look here. This is 4 times 10 times negative 1 is going to be negative 400. And here is 100 plus 100 is going to be 200 to the negative 1 over 2. And plus this one is going to be 200 to the half. And let's close the bracket times 4. And this one is going to be add the second one, which is 40 times 10, so it's going to be 400 times 1. It's not going to change anything. And here is 200 to the negative 1 over 2 plus 200 to the half, and times 1 is not going to change anything, times 4. And this one plus the third one, which is 400. And here is going to be 200 to the negative 1 over 2, and everything times 18. Now, here's the thing we have to do with close this one. I'm going to keep the pi out. We're going to distribute the 400. So here's the pi. And when I distribute the 400, you have to multiply it for both sides. Keep the pi out here. And it's going to be 4 times here is going to be negative 1600, and 200 to the negative half plus 4 times 200 to the half. I'm going to keep it like this. I'm going to keep this one as a square root. And now we're done from this one. I'm going to add this part by 400 times. So it's going to be plus 1600 and 200 to the negative 1 over 2. Okay, plus 4 times. So it's going to be 4, 200 to the half, 4, 200 to the half. And the last part is going to be 18 times 400. So 18 times 400 is going to be 7,200. So here's a plus 7,200 and 200 to the negative half. And I close the bigger parentheses. Now, if you look here, this one going to cancel with this one. So what's the leftover? The leftover is pi and here 400 square root of 200. So this one is look like 4 square root of 200 plus here also 4 square root of 200 and plus this is 7,200 over square root of 200. So now let's keep going. This is going to be equal pi. We can combine these together. So it's going to be 8 square root of 200 plus 7,2 over square root of 200. And then this one is going to be equal pi. Square root of 200 is going to be 10 square root of 2. So this one is going to be 8 times 10 square root of 2 plus 7,2 over 10 square root of 2. This one is going to be 80. So this one is going to be pi 80 square root of 2 and plus cancel this one with the 0. So it's going to be 720 over square root of 2. I think you have to keep going, simplify it. So we're going to keep going. Just need to simplify this one. So I'm going to rationalize this part. So this one is going to be equal pi, and here is 80 square root of 2 plus 720 over square root of 2. I'm going to multiply by square root of 2 and square root of 2. So this one is going to be pi, and it's going to be 80 square root of 2 plus 720 square root of 2 divided by 2. Now find the common denominator here. So it's going to be pi 160, we're going to multiply by 2. 160 square root of 2 divided by 2. I'm going to multiply, this is over 1, multiply by 2, and the plus 720 square root of 2 divided by 2. Then this one is going to be pi. Add these together now, it's going to be 80 square root of 2 divided by 2. And this one is going to be pi 440 square root of 2. And we're just going to write down 440 square root of 2 pi. This is what we got. I simplifying everything. So we're just going to type here 440 square root of 2. And outside, we're going to put pi. Let's check. Here we go. That's it for this example. It's longer steps. The main thing here, I needed to work how to find the derivative for the surface or for the volume. So you have to be careful when you do that. And step by step, everything is going to be right. That's it for this example.